Good evening, boys and girls. This is Mr. Meyer from Way Happy Studios, and we are on 8-8, the final section of Chapter 8. And so we are going to solve radical equations, and that is what we're going to see in this box right here. You're going to see there's about 3 little steps to solving radical equations. Step 1, isolate the radical. When you see a problem that has a radical in it, make sure you get the radical all by its lonesome. Step 2, raise both sides to the power that will cancel out that radical, right? You can use fractional exponents, or in this case, you can just raise it to whatever the index of the radical is. And then last step, solve it and plug it back in and see what you get. So let us try to see how this solving of radical equations works. So example 1 here, we got 2 of them. First thing, remember, step 1 is isolate the radical. So I'm going to move 5 over on both sides and have x plus 1 equals 11. I'm going to check to see, does that look isolated? It does. So now let's get rid of it. How do you get rid of a square root? You square both sides. Now before you never knew why, but now you know that that's got an imaginary 2 right here that we don't ever write. And so that's why we have to square both sides. I will square this side, I will square this side, and I shall get x plus 1, because the square and the square root cancel out, equals 121. And now I move that over, I get x equals 120, and there is my solution. You can even plug it in and check. 121 square root is 11, 11 plus 5 is 16, and voila, we are golden. Now look at B. We don't even get intimidated when there's a 7 out front, because again, we are isolating the radical. So I will divide both sides by 7, and that'll give me the cube root of 5x minus 7 equals, now that looks like to me it's going to be 12. And now I will cube both sides. So I have 5x minus 7 equals 12 to the third power, which I'm not sure I know what 12 to the third power is. So that's going to be 1728. So 5x minus 7 equals 1728. And now I will add 7. So 5x equals 1728 plus 7 is 1735. And it looks like 5 will divide into 1735 just nicely. And it will end up being 347. So x is 347. And now I'll probably need a calculator to check that back in. And just remember what it can't be. We couldn't have denominators zeros, and now we can't have negatives under radicals. And if you check that back out here, I'll show you. 5 times 347 is that, minus 7 is that. Raise it to the 1/3 power, because that's what cube rooting would do, and then multiply it by 7, and you get 84. I just worked my way right out of there, and it got it right back to it. Got me to the 84, so there's a check, and I am feeling super good. Now, sometimes when you write these problems, you will notice that you have 2 radicals, and they may be so mean as to have both radicals on the same side like this. I've definitely seen this before. And all you got to do is you make sure you move one of the radicals over to the other side. And that'll get you to example 2. And if you see 2 radicals, the big trick here is you isolate them on either side, and then you square both sides or cube both sides or whatever the index is. In fact, whatever the biggest index is, I would raise it to that power. So in this case, they're both squared. So I will square this side. I will square that side. Now you might notice something interesting. That 3 on the outside is going to get squared on the right-hand side. So when I square this, I get 7x plus 2. But over here, I get 9 from the 3 squaring. And then the 3x minus 2. Now, kind of tough to write next to it, so they were multiplied. So I'll make sure that I leave them multiplied. And now I go ahead and solve. So I got 7x plus 2 equals 27 minus 18. Oh, forgot my x. Now I just bring stuff over. So I'll add that over there. I get 20. Bring the 7 over. I get 20x. And I end up solving this and getting x equals 1. And now I can plug it back in and see. If I plug in a 1, I get 9 on the left side. Square rooted is 3. And if I plug it on the right side, I get 3 minus 2 is 1. Square rooted is 1 times 3 is 3. So I get 3 equals 3. And it all checks out. So why don't we let me ask you a question, and then I'll see you after you get that one done. Excellent. Now look at example 3. Just like before, don't forget that when you plug them in, you could get extraneous solutions. most likely you're putting a negative under a radical, so be careful. So as I go ahead and solve this problem, remember step 1, isolate the radical. Step 2, square both sides. Now this is going to be the tricky one because you have to square both sides. You can't do the 5 and the x individually. You have to square the whole entire right side. So the left side, piece of cake, negative 3x plus 33. But the right side, a little more challenging. What the heck is 5 minus x squared? So let's see, we're going to FOIL that out, right? 5 minus x times 5 minus x. That's going to give us 25. And then see, minus 5x minus 5 is negative 10x, and then plus x squared. So it looks to me like we will get x squared minus 10x plus 25. And now, hey, look, that's just a quadratic. Let's solve that bad boy. So move everybody over. I got 0 equals x squared. Now I'm going to add 3x, so minus 7x. I'm going to subtract 33, so minus 8. Now quadratic formula complete, the square factor. Oh my goodness, factor works again. We've just been very lucky with that. X minus 8 and x plus 1. So we have our answers. Our answers are x equals 8 from the first one and x equals negative 1 from the second one. We are finished. Then something in the back of our mind says, hey, that went really smooth. Maybe we should make sure we check our answers. Okay, so I'm going to start off by plugging the negative 1 in, and look, on the left side I would get 36, which is 6, and on the right side I would get 6. So boom, this one is gorgeous. And now I plug in the 8. On the right side I get negative 3, and on the left side I get the square root of negative 24 plus 33 is 9, and there's no way that 9 could equal a negative 3. That is not true. So therefore, this wasn't a case of where the negative was under the radical. It was where a radical equaled a negative number. That's not going to be true either. So this guy is extraneous. So we did everything right, but when he plugged in, he just didn't work. And so there you see extraneous when you're solving equations with radicals. And last but not least, we just learned that you can write radicals as exponents. So guess what? You can see problems that have radicals in them, but they're written as exponents. You do them the same way. Isolate the parentheses that have the exponent, then raise it to the power that will take care of that exponent. So in this case, the third power. Once I do that, the third and the 1/3 will cancel, and I'll be just left with 5x plus 7 equals 27. I will subtract the 7, 5x equals 20, and I will have x equals 4. Again, I should plug it in. 27 cube rooted is 3, and yep, that equals 3, so that works out. Same thing over here on B. Notice it's the square rooted problem, so I square both sides. Again, parentheses have got to get isolated. If there's anything added on the back, we'd move it over or divide anything over. But in this case, nothing spooky. We will square both sides. And as I square the right side, that's a beautiful thing, 4x plus 8. The left side, 2 squared x squared, so that is 4x squared. And now we just get everybody over on one side. Yuck, 4x squared minus 4x minus 8 equals 0. Ooh, I like that I can factor out a 4 or divide everybody by 4, so let's divide them all by 4. X squared minus x minus 2 equals 0. Factor this bad boy to x minus 2, x plus 1. And find your two answers where x is 2 and x is negative 1. And then again, I should probably check them just to make sure they work out. Plugging in a 2, I get a 4 on the left side, and on the right side I get 8 plus 8, which is 16. I get the square root of 16, so that checks. And then I plug a negative 1 in, I get negative 2 on the left side. Uh-oh, can't have a square root equal a negative. But I'm going to pretend I didn't notice. Is the square root of what? Negative 4 plus 8 is negative 4. And so now I got negative 2 equals 2i. That does not check. So bad news. The negative 1 was extraneous. And I have now solved. Great work. We're done with the chapter. Now it's all about reviewing and making sure we got it all. And I will see you tomorrow. Have a great day and stay happy.